Hi Chemistry, I hope you're well. In the past 2 or 3 weeks, we've been looking at atom configuration, and in the past class, we looked at all the different atom configurations throughout history. Today, we're going to look at one which is quite similar to the Bohr configuration that we saw over the past 2 weeks, and we call that the Lewis diagram. So let's start. So this is just a little introduction today. We'll have to conclude it in about a month's time. So we know that this is sodium. We know sodium has 11 protons. If it has 11 protons, it has 11 electrons. And then the neutrons is this number minus this number. So 23 minus 11 is 12. So 12 neutrons. But we're only interested in the electrons, of course. So the Bohr configuration, you should be well prepared now. First you draw your nucleus, and then we have 2 electrons in the first shell, and then we have 8 electrons in the second shell, and then we have 1 electron in the final shell. Okay, so that's your 11 electrons, and that's how they are arranged in Bohr configuration. So this was Niels Bohr, and he was the guy that came up with a theory for this configuration, and for this theory he won the Nobel Prize in 1922. Now, what we're going to look at today is a guy called Gilbert Lewis, and he was actually nominated for the Nobel Prize 41 times, but he never won. And there's actually a lot of controversy surrounding this about why he never won. But anyway, that's for another class. What we are going to look at is Lewis's contributions. And Lewis came up with this theory called Valence Theory. Now, Lewis theorized that, okay, all the electrons are important. However, the most important ones are in the outer shell. So we saw sodium has 1 in the outer shell. Lewis theorized that only this one is important, only the one in the outside shell. So he called these electrons valence electrons and called the shell the valence shell. So sodium has 1 electron in its valence shell, and this is its valence electron. Okay, all of these, they're important, but not as important as this one in the outside, in the valence shell, and this is the valence electron. So Lewis decided he was going to come up with a new way to draw them, because he thought that drawing it this way for every time you wanted to draw an atom was quite time consuming. So we need an easy way to draw it. And he came up with his Lewis diagrams. Okay. As only the valence electron were important, he devised a way to only draw the outer electron. All you do is write the symbol of the element, so Na for sodium, and then just draw a dot at the north, east, south, or west. Okay? So Lewis was the first to theorize that electrons would hang about in pairs if they could. So look at neon. Okay? Neon has 10 electrons, but we only want the valence electrons, so 2 and then 8. So that's why neon has 2, 4, 6, 8. And notice how they're arranged in pairs in a north, east, south, and west. Okay? Remember, only the valence electrons are required. So we've got argon, which has 18 electrons, 2, 8, 8. But as you can see, it looks very similar because we're only interested in the valence electrons. So even if they have a different number of electrons, they could have a very similar Lewis diagram. The only difference here is the symbol. Okay? So in a future class, we're going to look at how Lewis diagrams help us understand how different atoms bond, form connections to each other. This is a bond, this is a bond, this is a bond, and this is a bond. So these lines which connect different atoms, Lewis diagrams help us to understand how they connect to each other, but we're going to look at that in a future class, okay? A bonus point, maybe we can give a small prize to the first person to write in the comments the name of this molecule and the name of this molecule in the comments, not a private, public one, for this class in Google Classroom, will win a prize. The names of each of these molecules. So I want you to practice drawing some Lewis diagrams now for your work today. You can just do this in your notebook. Do it under the work that we've been doing before about all the different electron configurations. And I want you to draw Lewis diagrams for the following atoms: hydrogen, beryllium, aluminium, carbon, phosphorus, and oxygen. Remember, you just draw it like this. So chlorine has 17 electrons, okay? 17. So that's 2, 8, 7. So you just need to do a symbol, Cl, and then you only count the valence electrons, and you just do a little dots, okay? Take a photo of your notebook and upload it to Google Classroom, and I'll get that marked. So that ends our introduction to Lewis diagrams and valence electrons. We are going to come back to these diagrams in the future, but the Lewis diagrams are really important to help us understand what ions are, which we'll see next week. See you then. Bye-bye.